Okay, to get started today, we're going to take a look at this pattern. This is like your warm-up here, where you can see we've got these yellow, blue, and red blocks. This is figure 1 or stage 1, figure 2 or stage 2, figure 3 or stage 3. And the first thing that you're going to do is answer these questions. How many of each color tile will there be in the fourth figure? So you can count and see how many yellows there are in 1, 2, and 3. Use that information to figure out what figure 4 is going to look like and answer how many yellow ones will be in figure 4. We can count and see how many blue ones for each one, and we can use that pattern to figure out what's going to be happening and how many blue ones will be in figure 4. And again, how many of red will be in each one of these, including figure 4. You're going to go on to figure 4 and figure 5, and after doing figure 4 and figure 5, you might start noticing some patterns, so that then you could skip all the way to the 10th one. To the 10th figure, what would that look like? And then even more, we're going to generalize it to the nth. So take a second, finish discussing with your groups. Watchers of the video, you're going to pause and answer those questions on your own before you hit play. All right, we'll start with red. Let's see, in figure 1, I see that there's 1 red block. In figure 2, I can count and see that there's 2 red blocks. In figure 3, there's 3 red blocks. So how many red blocks are there going to be in figure 4? Are you noticing a pattern right now? 4 blocks. 4 red blocks in figure 4. How many would there be in figure 5? Logan? 5. And how many would there be if I skipped all the way to figure 10? Lucas? Very good. So we can see that the number of red blocks is directly related to the stage number. So stage 4, I don't want to draw it out, but I know that there's going to be 4 red blocks. I bet I even know where they're going to be too, right? Where are they going to be? Right in the top part, right? So how many, and since I'm not actually drawing, I'm going to write the number 4. How many here? 5. And how many here? 10. Okay, how many blue blocks? In stage 1, there's 3. In stage 2, there's 6. In stage 3, there's 9. Are you noticing a pattern here? Let's see, 3, 6, 9. How many blue blocks would there be in stage 4? Lainey? There would be 12. How many in stage 15? Sorry. I get so excited about the answer that I give it away. How many in stage 5? 15, since I just told you. And do you love my perfect drawings? They're so perfect, right? And in stage 10, skipping ahead, what is that going to be, Tyson? It is 30. Now, how did you figure that out? Because in the beginning, we probably could, those are such perfect drawings, aren't they? Love how perfect those are. In the beginning, we could skip count and just go 3, and 3 more is 6, and 3 more is 9. And we could skip count until I skipped a couple of stages. So how did you get that 30? Good. So you're recognizing that there's a relationship not just in how it's changing and growing, but 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. So we're seeing that the stage number multiplied by 3 is how many blocks there are. We can see this in the pattern too. I don't know if you guys saw this. Eyes on the screen. Do you see how the red and blue, like there's 1 red block, so there's 1 blue block right next to it. And we have 1 yellow block and there's 1 yellow block right next to it. Sorry, 1 blue block right next to the yellows. And then we've got the one in the middle. So we can kind of view this pattern in 3 groups. Like this one, there's 2 red blocks. So how many blue blocks are next to it? 2. And here the yellow blocks are too high. So how many blocks go with that in blue? 2. And of course, we've got our section in the middle that has 2. So you can kind of view it in like these sections too. In here, there's 3 red blocks. So we can see 3 blue blocks to match it. Our yellow is 3 high, so we can see the blue is 3 high. And how many in the middle? 3, exactly. So we can also kind of view that pattern too and see why we're multiplying by 3, because it's like having 3 blocks in 3 different places. Or here it'd be having 4 blocks in 3 different places, 5 blocks in 3 different places. So 5 times 3 is 15. Okay, we got some good things going on here, and that's all going to help us when we get to figure N. Let's move on to the yellow. How many blocks are there here? 1. How many yellow? And here? It's not a steady growth like we saw before. Is there still a way that we can figure out what it's going to look like? How many are there going to be here in stage 4? How many yellow blocks in stage 4? Camden? It is 16. How did you get that number 16? So you actually drew them all out? It did take a long time, but when you drew them out, how did you know what it was even going to look like? We added 3 to each side. Double check. Let's move on to 5 and maybe we'll start seeing a pattern. How many blocks would be yellow in stage 5? Okay, go back and discuss. We're pausing the video. Go back and discuss. Okay, time's up for discussion. How many blocks were there going to be in stage 5? Rhett? It is 25. How did you get that? Did you count it? Did you draw it and count it all up? I'm sorry, what did you say? But how did you know what that even looked like? You're right. But can you describe it? Because we have a lot of students who don't even know that it should be 25. So how did you know that it should be what you said it should be? Camden? Okay, but why is it 3 times 3 is 9? But why? Let's back up. How many blocks are here on stage 2 that are yellow? 4. Are they all stacked straight up on top of each other, making a nice tall tower? Yeah? I see some people saying yes. Let's try that again. Are all 4 of these stacked right up on top, making a nice tall tower that's 4 tall? No. Are they all stacked to the side, making a nice long street that's 4 long? Yeah? So they're all stacked 1, 2, 3, 4, like that? That's how they're stacked? No. How are they stacked? We have 4 blocks. How are they arranged? We go up. How many? And how many? Okay, so how are they arranged? Is it a nice tall tower that's 4 tall? Is it a long street that's 4 long? No. How are they arranged? They're going up 2 and across 2. So when I get to stage 3, I have 9 blocks. Again, let me ask, are these 9 blocks stacked right on top of each other, making a nice tall tower that's 9 tall? No. Does it make a staircase that I could climb up? No. Is it a nice long street that's 9 long? Okay, I need you to go back to your groups then and discuss. How are they arranged? How do we have those 9 blocks arranged? What's the pattern? What's the figure? Talk to each other. And again, how are they arranged? Should I take those blocks and make a staircase? No. How are they arranged? Lainey? 3 up and 3 across, which means how many total are there? If they're up 3 and across 3, 9. How are they arranged here for the 16? How did we figure out that it was going to be 16 in the beginning anyway? Are they going to be making a staircase? No. Are they going to be a nice tall tower? No. How do I know how they're arranged? What is that going to look like, Camden? Up 4 and across 4. And so if I go up 4 and across 4, how many blocks are going to be there? How do you know that? 4 times 4 is equal to 16. How are they arranged here? Why is it that Rhett did 5 times 5 is 25? Tyson? 5 going up, 5 going across. So maybe we're finally ready. In stage 10, how many yellow blocks are there going to be? Please go back and talk with your groups one more time. Is it a nice tall tower? Is it a staircase? What is it going to look like? Haley. And so if it's going up 10 and over 10, how many blocks are going to be in a 10 by 10 square? Maddie. No, try again. Lainey. 100. Up 10 and across 10 is 10 times 10, not 10 times 2, 10 times 10, which means there's going to be 100 blocks here. Do I even dare ask about figure N? In figure N, let's start with the easy one. We know what it's going to look like. In figure 4, there were 4 red blocks. Figure 5, 5 red blocks. Figure 10, 10 red blocks. So how many red blocks will there be in figure N? N red blocks. Do we know where they're going to be too? Yeah, a nice tall tower up here. How many blocks there? N. You found some great patterns with blue. 3 red blocks in figure 1, 6 in 2, 9 in 3, 12 in 4, 15 in 5, and you even knew that there was going to be 30 in 10. How did we get that 30 again? Camden? Yep, 3 times 10. Where did the 10 come from? Because that's the stage number. What's our stage number now? So how many blue blocks are there going to be? N? Are you sure? Let's try that again. In figure 3, were there 3 blue blocks? No. In figure 4, were there 4 blue blocks? No. So we can't say that figure 4 has 4 and figure N has N, because that's not the case. Figure 4 had 12. Figure 5 had 15. Figure 10 had 30. Camden? 3N. How are you getting that? Because you take the stage number and you multiply it by 3. The exact same thing that you did for all of these others. 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. 10 times 3 is 30. So what should I do? I should take that stage number and multiply it by 3. And what's N times 3? Fun fact, it's not N. It's 3N. How many yellow blocks? Again, stage 3, it was a 3 by 3 square. Stage 4, it was a 4 by 4 square. Stage 5, 5 by 5 square. Stage 10, a 10 by 10 square. How many blocks are going to be here? Yellow. Lucas? Yes, and an n by n square is going to have how many blocks? I heard n and I heard n squared. N squared is correct. Please understand why n makes absolutely no sense. In 4, were there 4 blocks here? No, it was 4 times 4, which is 16. In 5, was it 5 blocks here? No, it was 5 times 5. You can't just say it's n, because n means that number. It is n times n, which you should know as 8th graders that that is n squared. Fun fact, do you see how it's n squared and it is a square? Do you think it's called squared for a reason? Yup, sure is. It's because it makes a square. That was a lot rougher than it should have been. I don't have high hopes for this one, but I hope that you can prove me wrong. At your table, you have colored pieces of paper that we are going to sort. So, these pieces of paper show graphs and they describe different situations. You are supposed to match the situation to the graph, and I don't think that my last class mixed them back up. Will you please mix them back up so that you actually can learn from this activity instead of just having the work already done for you? Put them all on your desk, scatter them, squish them all up, shuffle them. Now, I'm going to try and prevent any issues by just doing the first one with you so that there's no excuses. Again, we are matching each situation to its graph. Here's the way to do it. We're actually going to skip ahead. This part 2 shouldn't be done until we've already matched everything, but we don't have time for that. We're just going to match everything right now. And to match them, we're needing to know the answer to this question. How can you find the slope from the graph? So let's pick graph 1. Will everyone please find graph 1? You cannot write on these cards, but you can still do the work even though I'm not letting you write. How do we find slope from a graph? Because that's what question A is asking. How can you find slope from a graph? We've done this before, have we not? We took a test on this, did we not? How do we do it, Logan? You find the rise over the run. And where's the best place to measure rise and run? Probably from some crosshair points, right? Okay, here's a crosshair point. Found it. Where's another crosshair point? Lucas? Careful. Look again. If y is 15, where's that point? What's the x-coordinate with that? 1, and that matters. There's another one here too. And another one here. And another one here. That's okay. But you have your own graph 1 in front of you too, right? Yeah. What is the slope? We need to find the rise. So what's the rise? Nope, it is not up 1. Look again. Lainey, it is up 5. Why is it up 5 and not up 1? I went up 1 box. Because we're counting by 5. So when I'm going up 1 box, I'm going from 10 to 15, which means the rise is 5. What's the run? Are you sure? Check again. Sure, I went over 2 boxes. How much did I go over? I went over 1. So you've got to pay attention to the scale. Not just going up and down, going across as well. So the rise over the run. 5 over 1. What's 5 over 1 simplify to be? 5. Now will you please go through and look through your situations? Because each situation, you don't even need to read the whole story because it says at the end, the slope is, and then it lists a number. Will you find the situation that says the slope is 5? Yeah, it should be quite easy. All of my classes have struggled with this way more than they should have. You guys aren't going to struggle, are you? Have you found the one that says the slope is 5? Which one says the slope is 5? Haley? Situation C. Because it literally says exactly what we just did. The slope of the line is 5. So we're going to match situation C with graph 1. Can you guys repeat that process on your own? Where should we be starting? Should we be starting with the situation or starting with the graph? Okay. Find the slope of the graph. Find the situation that matches it. Those watching the video, this is not something that you can do very easily at home unless you print the document that I will post on the calendar and cut it out yourself. Otherwise, you'll just have to wait until we go over the answers. All right, students in class have had a chance to sort through these. What I suggest is as I go over each one, pause in between so that you can find the slope yourself if you haven't already printed off that sorting activity. So when I'm checking for the rise and the run, the first thing I have to do is look for some crosshair points, and I see these crosshair points too. You might be tempted to say that the slope is up 2 over 2, which is definitely not the case, because if I'm going up 2 boxes, I'm actually going up 10. And if I'm going over 2 boxes, I'm actually going over. I was at 0 and I'm over at 1. This gives me a slope of 10 over 1, or simply 10. And now that I know the slope, it's very easy to match it with situation A, which says the slope of the line is 10. Graph 3, our process doesn't change. We're looking for some crosshair points. Here's one. Have to search a little bit further. Looks like here's another one. Finding that rise first, up this much. So yes, it was 3 blocks, but notice what we're counting. 40 to 60. So 40, 50, 60, 70. That means I'm going up 30. And I'm running, so the rise is 30. The run, I went all the way over 4 blocks. Yes, but that is a run. Sorry, not of 4, but of 2. So our rise over our run, 30 over 2, is equal to 15, which is why graph 3 matches situation D, where it says the slope of the line is 15. Graph 4, looking for those crosshair points so that I can find the slope of the line. I see a crosshair point here, and the next one, looks like I can stop here, but I'm going to go to the next crosshair point so that the run is 1. And when the run is 1, the rise is, I'm going from 0 all the way up to 40. So the slope is 40 over 1, which simplifies to 40. Graph 4 matches with situation F. Graph 5, come back with me now if you were not keeping up. Graph 5, find the slope of the line. A lot of students made a lot of silly mistakes here. What is the slope? We're going up 1 over 4. So the rise over the run, 1 over 4. So we need to look for the one that has 1/4. Oh no, none of them say 1/4. Yeah, but 1/4 is the same as 0.25, so that's why graph 5, situation E, where the slope is 1/4, 1/4 or 0.25. And that gives us graph 6 matching with situation B. And again, looking for some crosshair points, I would say that the best crosshair points to find would be this one and this one, where I'm going up 20 and over 5. So the rise over the run is 20 over 5, but 20 over 5 simplifies to 4. And that one took a little bit harder. If you were just looking for some crosshair points down here, you weren't going to find them. You had to go a bit further to find those crosshair points. The next thing that we're going to be doing is we need to ask the question, what does the slope mean in each situation? So what does it mean? Remember that the slope is rise over run. But the rise, as it says in this thing, the graph represents the amount in the piggy bank, which is Y. That's our rise. So the amount in the piggy bank is measured in dollars. Over X, that's our run, and that is weeks. So what does 5 over 1 really represent? That's the dollars per week. That's what we're going to be doing as we come back. And I guess that's it for today. Go ahead and get cleaned up.